Now I do. Okay, so why do we learn the unit circle? Well, we're going to get into that now. But before we do, we're just going to recall a few things because it is important. So we know that the sine ratio is opposite over hypotenuse, y over r. Okay, the cosine ratio is adjacent over hypotenuse, x over r. And tangent is opposite over adjacent, y over x. If we were to take the reciprocal of tan, we would have cotangent, and so we just flip the numerator and denominator. So cotangent theta is x over y. Okay, if we're looking at the unit circle, the radius is 1, or the hypotenuse is 1. So instead of having these r's here, they're 1. So y over 1 is just y. So we can conclude that sine theta is equal to y. And cosine, if we put 1 in for our r, we would just have x over 1. So cosine is just x. If you guys want as well, you can summarize that we have an ordered pair then of cosine theta, sine theta. Okay, ordered pair. I believe it's written here already for you, but I just wanted to highlight it there twice. Okay, and lastly, if sine theta is y and cosine theta is x, then we can write tan theta as sine over cosine, because tan was y over x, but sine is y, cosine is x. And then we can take the reciprocal, cotangent would be the reciprocal, so we'd have cosine over sine. And we just flip them. So using those pieces of information, we're going to now try and figure out the value of some of these trig ratios. Okay, so use the unit circle, or we can use our special triangles to find the exact value of the trig ratios for a rotation angle of 300 degrees. And it says, give each answer with a rational denominator. So that means that we can't have a radical in the denominator, okay? So for sine 300, what we're going to do is we're going to use our unit circle. So you guys have the cheat sheet in pink or your own cheat sheet that you created. Hopefully it's right though. Okay, and I want you guys to go from 0, and we're going to go all the way to 300. Okay, right here. Sine, what letter is it from an ordered pair, x or y? Okay, it's the y coordinate. So if we were to go on our unit circle all the way to 300, okay, we would have, look at your unit circle, and we would have 1 over 2 and negative root 3 over 2. Okay, that's our ordered pair. Sine is talking about the y coordinate. The y coordinate here we have is negative root 3 over 2. Okay, so that's our answer. Negative root 3 over 2. Just by looking at the unit circle, we have our answer. Hey, what does cosine stand for in an ordered pair? The x coordinate. And the x coordinate at 300 degrees is 1 over 2. Okay, you can use your unit circle to find that. We have 1 over 2. And how do we find tan? It's y over x. So tan theta is equal to y over x. Okay, well our y was negative root 3 over 2. And our x was 1 over 2. So what happens to the 2's? Cancel out, and we're left with negative root 3. Okay, cosecant 300, that's the reciprocal of sine. So all we have to do is take the sine ratio, and we're just flipping it. So we now have 2 over negative root 3. Are we allowed to have a radical in the denominator? No. Nada, so we're going to rationalize. Multiply by root 3 over root 3. Okay, and we get 2 root 3 over negative 3. secant 300. Secant is the reciprocal of what? Cosine, very good. Okay, well cosine we figured out was 1 over 2. So the reciprocal of that would just be 2 over 1. Don't need to put the 1 though. Okay, and lastly, cotangent is the reciprocal, x over y, or if this is like negative root 3 over 1, we just flip the numerator and denominator, so we have 1 over negative root 3. But we're not allowed to have a square root in the denominator, so we're going to rationalize, multiply by root 3 over root 3, and we get root 3 over negative 3. So that's using the unit circle, but there's an alternative method. We can use our special triangles. Okay, so first of all, I'm just going to draw a set of axes. And then I'm going to draw my rotation angle to 300 degrees. And I'm going to create a reference special triangle. So if I rotate it to 300 degrees, what is your reference angle? 360 minus 300, 60 degrees. Okay, so that means this is 30 degrees here. So I'm going to have root 3 over 2, 1 over 2, and radius of 1. Because this point is in the fourth quadrant, my y will be negative. So now, if I'm trying to find sine 300 degrees, and I know that is opposite over hypotenuse, but my hypotenuse will always be 1. So it's just the y coordinate, and I look at my special triangle, and I know it's negative root 3 over 2. Okay, so if you have the unit circle already constructed, it's very easy to do it how we did before. You just look at your unit circle, 300, oh, my y value is negative root 3 over 2. If you don't have the unit circle constructed, perhaps you want to use your special triangles. Okay? Just be cautious that you put it into the actual quadrant, and you be careful about the sign. If this point is going down, y value is negative. Okay? Alright, number 2 is exactly the same, except for the angle measurement is given in radians. So for those of you who like radians, go for it. I like degrees, so I'm just going to do a quick conversion. So 3 over 4 pi. Okay, I've got to multiply by 180 over pi. What do we get? 315? No? What is it? 135. Okay, that's right, because it's less than 1 pi, so we've got to be smaller than 180. Okay, so 135 degrees. So let's draw this. I'm going to use special triangles. Reference angle will be 45 degrees, and I know that my x is root 2 over 2, and my y is root 2 over 2. If we're in quadrant 2, though, what do I need to remember about the x value? Negative. Okay, cosine, x or y value from the ordered pair. Okay, I'll just write out the ordered pair, negative root 2 over 2 and positive root 2 over 2 for your y. Cosine is referring to the x coordinate, so your answer is negative root 2 over 2. If you already have the unit circle constructed though, then you can just have a look at it, find 135, and the x coordinate is negative root 2 over 2. Okay, so by looking at the unit circle, it's quick, it's easy, done. Okay, but if you don't have it, special triangles might be useful. Okay, 5 pi over 3. What angle are we looking at? 300. Have we already done that? Yep. Already completed. So do we need to do that again? Don't think so. Okay, tan 600. Unit circle only goes to 360. What are we going to do? Keep on rotating. Good. So we have a rotation of 360 plus 240. So what's now your reference angle? You're basically looking at tan 240 now. Okay? So tan is y over x, What are the ordered pairs at 10, 240? Okay, we can look right on our unit circle. Let's find that. We have negative 1/2 and negative root 3 over 2. So just by looking at the unit circle, I know my x and I know my y. Tan is y divided by x. So now I just divide those. So I have negative root 3 over 2 divided by negative 1 over 2. So that's my y divided by x, or opposite over adjacent. 2's cancel out, negatives cancel out, and you're left with the square root of 3. And if you don't have the unit circle in front of you, you can use your special triangles. Okay, last one, cosecant 3 pi. How many rotations are we talking about? 1.5, perfect. Okay, so full circle is 2 pi, and then we're going another pi. So that puts us at 180 degrees. Okay, so the point that falls at 180 degrees would be negative 1, 0. Cosecant is the reciprocal of what? Sine. Sine theta is normally y over r. Okay, so then cosecant theta is r over y. What is your r always on a unit circle? 1. We have 1 over, what's your y? 0. Okay, because we're not moving up or down. We're right along that axis. Can you divide by 0 though? No. So yeah, that's my ratio, but we can't divide by 0, so this is undefined. Okay, not possible. So how are we doing so far? Would you guys be able to do a couple questions like this on your quiz tomorrow? I'd say so. Okay, your choice. You can use the unit circle or the special triangles, but you better hope that you get the special triangles and the unit circle correct tomorrow, because if you don't, then you can't get those answers correct. Now, how can you check? How can you check to see if you got your answers correct? Yeah, you have a bit of a resource, calculator. Well, why don't we check sine 300? So let's go sine 300 in your calculator. Tell me what you get. Negative 0.8 something. 6. 6. Okay, hold on. Okay, now if you check your answer, negative square root of 3 divided by 2. Do you get that same decimal? Okay, that's what you want. So if you're unsure, just check. Verify your answer. It's a good habit. Okay, class example number 3. So we're going to use our calculator to determine to 4 decimal places the coordinates of the point on the unit circle that rotates to 2 over 5 pi. And I'm a degree kind of girl. I like degrees. So I'm going to calculate it. 2 divided by 5, and then multiply that by 180. I get 72 degrees. So we have a rotation to 72 degrees. It's in quadrant 1. Telling us we got to figure out the x and y coordinate. What do we remember about the x and y coordinate? What does x represent? Cosine. I'm going to put the degree right in, okay? So the x coordinate will be cosine 72 degrees, and the y coordinate refers to sine 72 degrees. Okay, this is our reference angle, 72. So we just need to calculate what is cosine 72 degrees and what's sine 72 degrees. And we're going to round to 4 decimal places. So first calculation, first of all, make sure you're in degree mode, and you're literally plugging in cosine 72 degrees. Xander, what'd you get? I'll tell you if you're right or wrong, don't worry. So we're rounding to 4 decimal places. 0. Okay, perfect. Now, has anyone calculated sine 72?
Yep.
Joe's, what'd you get?
0.9512.
And that's rounded? Perfect. I'm getting 1, 1.
Oh yeah, 1, 1. I meant that.
Okay, just checking. So just be careful with your rounding. If that was a numerical response, just a little mistake could cost you a question. So be careful. Okay, so we found the coordinate. Just by memorizing that cosine relates to x and sine relates to y. Okay, so you have to know that in order to answer a question like this. Okay, next one we have 2 points. They're on the unit circle. An object rotates counterclockwise from point P to point Q. We have to figure out the angle that it's rotated. So I always like to draw a picture. Okay, P has a positive x and a negative y. Which quadrant? Yeah. You're quick, Joe. Okay, and point Q has a negative x and a positive y.
Is that 3 or is that 2?
That's 2.
Quadrant 2. Okay, x will be negative, y is going up to positive. So Q will be here. Okay, so going counterclockwise, we need to figure out what is the angle that rotates from P to Q, counterclockwise. So what you're going to do is you're going to create a terminal arm going from the point P to the origin. And then you're going to connect to the x-axis and make a little triangle. If you have an ordered pair of root 2 over 2, root 2 over 2, what is your reference angle? 45, good. Okay, awesome. Okay, now let's go on the other side. We're going to connect a line from the origin to Q. And then draw down to the x-axis, and we need to figure out the reference angle here. I'm just going to label this to help out a little bit. Okay, we know it's going to be 30 or 60, but my x is 1/2, and my y is root 3 over 2. So what's the reference angle? 60, good. Okay, we need to figure out the rotation angle from P going counterclockwise to Q. So I know that I have 45 degrees. Okay, and then from here to here, 90 degrees. And then what's here to here? How'd you get that? Okay, 90 minus 60. You have another 30 degrees. Question?
Oh, just trying to figure it out.
What was your question though?
I was just like, why is it, how do you know it's 60 and I know it's 45, but it's because of the points, right?
Yeah, exactly, because of the ordered pairs. And that's by memorizing the special triangle. Anytime you see a root 2 over 2, that should be like 45 degrees. Okay? And if you see a half in root 3 over 2, then you have to think, oh, okay, is that 30 or 60? And I usually draw it out, and I know that 30 times 3 is 90. That's just how I memorize it. Okay? So then we just add these up. We have 45 plus 90 plus the 30 here, and we get, what is it? 165? Yeah. Okay, very good. Do you guys remember logarithms? Somewhat? Well, we get to see them again. So without using a calculator, okay, key instructions here, without using a calculator, we have to determine the exact value of log base 2 cosine 7 pi over 4. Now I see someone's picking up their calculator right away. Is that you? That's okay, because that's how we can check it at the end. But how are we going to do this? algebraically. Let's start with cos 7 pi over 4. Maybe you guys are getting better than me at this, but what is the degree? 225?
704?
Yeah, 7 over 4. 315. Ah, see? You're getting better than me. Okay, so we have cosine 315. Let's draw this out. We'll rotate to about here. Okay, what's your reference angle? 45 degrees. Okay, good. So then we have, I guess I could just put the ordered pair. No, I'll put my x value. So we have root 2 over 2. And my y value will be negative root 2 over 2. Okay, because we're going down. So if you want, you could write the ordered pair, root 2 over 2 and negative root 2 over 2. Happens to be the same point of p from the question before. So ignoring the log for 1 second, cosine 315 degrees, or cosine 7 pi over 4, okay, what is that equal to? Cosine is which value in the ordered pair? It's the x coordinate, so root 2 over 2. So now that we know that, we're going to plug that into here. So we're left with log base 2, and now cosine 7 pi over 4, that's actually root 2 over 2. So let's put that in there. Just remember, we can't use a calculator yet. Actually, ever. So what am I going to do? How can I figure out the value of this without using a calculator? Change what? So if I change that to an exponent, how's that going to help us? Right? Won't do anything? Okay. I mean, we could try it. I'm just going to make up that is equal to x. 2 to the power of x equals root 2 over 2. What do I need to do to this side in order to figure out that x? Nope. You need to get a common base. So we have 2 over x equals 2 to the power of a half over 2. Remember? So we can take a square root and change the radical into an exponent. Because the index on the square root is 2 and the exponent is 1. Similarly, say we had the 4th root of 5 to the power of 8. Nah, I don't like that. 7. Okay, then I would have 5 to the power of 7 over 4. The index is always the denominator in the exponent. The exponent is always the numerator in the exponent. So just a bit of review from exponents and logs. Okay, so I've converted to an exponent. Now I have the same base. What can I do with these exponents? If you're dividing the same base, subtract. So we have 2 to the power of x equals 2 to the power of 1/2 minus 1. So we get, I'm just going to go over here, 2 to the power of x equals 2 to the power of negative 1/2. Now we have the same base. What do I do with the exponents? Set them equal, and we have x equals negative 1/2. Yay. So yeah, we can solve this by creating an exponent, but then we have to do a few tricks to the trade to get our final answer. I'm going to show you guys an alternative route for this. I'll just give you a moment to copy it down. Yeah.
When you put it in the calculator, oh maybe that's why. One sec.
Were you in radian mode?
I think I did it.
Should you be in radian mode or
Okay.
So if you're putting 7 pi over 4, you need to be in radian mode.
Okay.
but if you're using the 315, degree mode. So I just want to go back to this step where we had log base 2 of root 2 over 2. So what I could do is I could keep it as a logarithm, but I could write it so that the argument has a common base of 2. And then I would have to subtract the exponents within the argument, which gives me half minus 1 is negative 1/2. And when we have an exponent, what can I do with that? Do you guys remember the power law?
Oh yeah.
Perfect, Emily, you can put it out front. So we have negative 1/2 times log base 2 argument 2. And do you guys remember when you have the same base and argument what that equals? 1. Okay, so we have negative 1/2 times 1, so your answer is negative 1/2. So, lucky, if you put this in your calculator, you would get the answer. You could put it in exact form. But there's going to be some cases where this won't be as pretty. Maybe it's a root 3 over 2. And then the answer doesn't work out as nice or something. So you can try it and put it in your calculator, and if you get a fraction or a decimal that can go into a fraction, awesome. But sometimes you might end up with, say, like negative 0.866, blah, blah, blah. If you've memorized what that decimal turns into, you will know it's root 3 over 2. But that's just a memorization tool. It's not knowing the steps of how to evaluate a logarithm. So it doesn't hurt to review these steps, even if you could have evaluated using your calculator. Okay, moving on. Long story short, always check your work, okay? Example 6, we have a point that lies on the unit circle. We have to figure out the angle where the angle is made by the positive x-axis and the line passing through A. So let's draw a picture again. That's fun. Negative x, negative y. What quadrant? 3. So point A goes here. So I need to figure out what is the angle from the positive x-axis to point A. So let's draw a little triangle. Okay, the x is given by negative 0.6157. The y is given by negative 0.7880. How am I going to find out this angle? What trig ratio uses the opposite and the adjacent? 10. Good. So tan equals y over x. And my y is negative 0.7880. And my x is negative 0.6157. So how do we calculate angles? What do I have to press on my calculator? Second tan. Good, so we're going to go second tan. And don't worry about the negatives. We're just going to put 0.7880 divided by 0.6157. That's going to give you the reference angle.
Could you also just do cosine? Because you know cosine is x. I got the same answer.
I guess it lies on the unit circle, so yeah, you could do that. You could do sine as well. Yeah. Okay, so if you guys didn't hear that, well, first of all, let's just get this angle, and then I'll talk about what Ryan just said. Okay, what did you guys get for the angle?
52.
Without rounding?
51.997.
Okay, so that's how many degrees we got. Now what Booker was saying, instead of calculating tan, could we use cosine or sine? And yeah, we could. So we know that cosine theta will equal the x-coordinate, and we know that the sine theta will equal the y-coordinate. So let's just say we use sine. Okay, sine was, or y-coordinate was negative 0.7880. So if I go second sine, and I put 0.7880 in there, I will get my angle, and that should also be 51.997 degrees. Okay, so if you're a bit lazy, doesn't matter, it's not lazy, it's efficient. Okay, if you don't want to plug two numbers in, you could have just used sine or cosine. Okay? You get the same thing, Bernie?
Not really.
Really? Let's check it.
Unless I did it wrong, but let's say a little bit off the decimal places. Is it cosine?
Oh, sorry about that. You're definitely in the green one.
Yeah. Yeah,
Now post.
Cosine 6.56.
It's on the unit circle, so it's over what?
Yeah.
So, sine, whatever y is, which in now
Okay.
sine.
So, what Bernie is noticing is that actually it's off by 1,000th. Okay, so just a little bit off. And my assumption is the points that they came up with were rounded. And because they're rounded, that means these values are going to be a little bit off. Okay, we're going to try to figure out the angle to the nearest degree. So would 1,000th affect your overall angle? Okay, if this third decimal is off by 1, is it going to affect it?
No, because if those kept going, we just get 52.
Pardon?
Like, or, so, yeah, those
Yeah,
kept going,
if
just
we
get
rounded,
52.
we would get 52 degrees. Okay, so to figure out the total angle, whether we're 1,000th off or not, okay, it's gonna, if we rounded that, we'd get 180 degrees plus another 52. Okay, so let's call this angle happy face. Okay, angle happy face is gonna be equal to theta plus 180 degrees. Theta was our reference angle. Okay, let's just round that to 52 degrees. We add that together, we're going to get 232 degrees. Okay, so that is the rotation from the x-axis to point A. Okay, and like Booker was saying, you can use tan, sine, or cosine calculator. So on the next page, we've pretty much done this part already, talking about how we can use the special triangles to figure out the ratios. The workbook tells you you need to memorize this chart. Do you need to memorize this chart? No, but you do need to memorize those 3 special triangles, okay? Because you can construct these ratios as long as you get the special triangles. Okay, so we can just skip forward. So we've already done these kind of questions. And we're going to explore the equation of the unit circle. Alright, so we have a point, any given point on a unit circle. That point will be xy, just like we can see in the diagram. If we were to construct a triangle within that diagram, from the origin to the outside and back to the x-axis, we would have a radius of 1. We would have a vertical height of that triangle as y and a horizontal length of x. The equation of this unit circle will be x squared plus y squared equals r squared. But what was r? 1. And what's 1 squared? 1. Okay, so the unit circle equation is x squared plus y squared equals 1. Alright, so now that we know the equation of the unit circle, we're just going to use that equation to test if certain points lie on that circle. So given a point x and y, we're just going to sub that into the unit circle equation. So let's test. Sub into x squared plus y squared. We're going to see if left-hand side equals right-hand side. So we need to prove that. the x coordinate was 1/2. Sub that in, and the y coordinate was 1/2. We're going to sub that in. If we square 1/2 and add it with another half squared, do we get 1?
Negative.
No. Okay, this point does not lie on the unit circle. Okay, let's test the next one. So we need to prove that left-hand side equals right-hand side for x squared plus y squared equals 1. Our left-hand side will be 16 over 65 squared plus negative 63 over 65 squared. Does that equal 1?
Yeah.
If you've already calculated it, you should get that 1 equals 1. So yes, this point lies on the unit circle. So you guys get the point? Alright, next question. The point P, negative 1 over 5 and y, lies on the unit circle in quadrant 3. We need to find the value of y. So let's draw a picture. Okay, it's in quadrant 3, so I'll give my quadrant 3 a little more room. We have the point negative 1/5 and y. So hopefully you guys have noticed every single time we have a point or we're trying to find an angle or terminal arm or whatever, I'm always drawing a triangle from the origin to the x-axis. And you're pretty much going to have to do that for all these types of questions. So I'm going to first do that, then I'm going to label the triangle. I have an x value of negative 1/5. I don't know my y. On a unit circle, what is your hypotenuse? 1. Good. How am I going to find that third side? Good. What's that called? Pythagorean theorem. So we're starting with x squared plus y squared equals r squared, or in this case 1. Okay, and we know that we're going to have to solve for y, so you can rewrite it as y squared equals 1 minus x squared. So y squared will equal 1 minus negative 1 over 5 squared. And from there, what fraction do you guys get? Without square rooting it. Just what's 1 minus negative 1 over 5 squared?
12 times.
Pardon?
12 times.
And as a fraction, what do you get? It's just a little bit easier.
24 divided
24 over 29?
5.
25, sorry. So that's y squared. Let's just go a step further. And we will need to take the square root. Okay, so take the square root of that. If I went like this right away, would you guys know what I did? Maybe not. Okay, the square root of 25 is 5, so that's my denominator. And just a little review, square root of 24 can be broken up into a perfect square times 6. The square root of 4 is 2. We can't take the square root of 6. Okay. So y is equal to 2 root 6 over 5. We're in quadrant 3. Will y be negative or positive?
Negative.
Negative. Good. Okay, so we found our y. Part B, the point P lies on the terminal arm of a rotation angle. We need to find the exact values of sine theta and cotangent, secant theta and cotangent theta. So I'm going to draw another picture. A little bigger triangle this time. I know my x value is negative 1/5. My y value we just solved for, so negative 2 root 6 over 5, and we have a radius of 1. Secant is the reciprocal of cosine. Cosine is x. So secant will be 1 over x. Okay, what is your x? Okay, so 1 over negative 1 over 5. If we divide that through, we get negative 5. Okay, or you could have just looked at cosine. The reciprocal of that is negative 5. So secant theta is equal to negative 5. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So now we're doing adjacent over opposite. So let's plug in our x over y. We have negative 1/5 divided by negative 2 root 6 over 5. What happens to those 5's? Cancel out. The negatives will also cancel out, and you're left with 1 over 2 root 6. You allowed to have a rational in the denominator? Sorry, radical? No. So we're going to multiply by the square root of 6 over square root of 6, and we get the square root of 6 over 2 times 6 is 12. Okay, so cotangent theta is equal to root 6 over 12. How are we going to find the angle? Right here. For part C. What could I put in my calculator? Second anything. Well, we gotta put something. So let's pick one. Do you want sine, cosine, or tan? Cos? Okay. So we're gonna do second cosine, and it's gotta be the x value. So 1 over 5. And that will give us our angle. Okay, don't put the negative inside the brackets. That's just telling you it's in quadrant 3. What'd you guys get? 78 point something degrees. Read the question closely. What does it want? Nearest tenth, and what's the domain? In radians, and it also says nearest tenth of a radian. So we have to take our degree measure, 78 point whatever, and we're going to multiply that by pi over 180. And this time we need to actually multiply by the pi, because they want it to the nearest tenth. So to the nearest radian, what'd you guys get? Oh, that's fine. Okay guys, my apologies, sorry.
I had something to
So, guys, actually, I just missed a little piece, and I'm kind of glad I missed it because this could be a very common mistake. Okay, we figured out this reference angle, but where's the angle actually going to? It's going to that point from 0 to there. So what did we have to add to the 78 first? 180, sorry about that. So 78 point whatever plus 180. Okay, don't round your answer. Whatever you get there, you're going to multiply by pi over 180. So let's just... So you should get 258.463.
What does he have? 4.5.
I don't think that's possible.
And then we multiply that. And what'd you guys get? Hopefully 4.5? Yeah? Good. Okay, 4.5 radian. You don't have to put radian, but it's just nice to see radian so that if you look back, you knew what you were talking about.
It's in the storage room.
And we've got one more question, so bear with me.
Maybe it's Brucey.
Focus.
And make eye contact. Can you feel
Okay, what's the equation of the unit circle? Review. The equation of the unit circle. X squared plus y squared equals 1. Okay, what was the 1 again? Think about Pythagoras. This is actually like r squared, right? But the unit circle, we ended up with 1. Okay, so now we need to find the equation of a circle with the center at the origin, but this time the radius is 8. Good, so if r is 8, we just replace that with 8. 8 squared is 64. So the equation will be x squared plus y squared equals 64. Now they're telling us there's a point that lies on the circle, and we need to figure out what are the values of b in the y-coordinate. So using this equation, we can sub in what we know. X is -4, y is b root 3, and that equals 64. So let's just expand a little bit. We get 16 plus 3b squared. Okay, don't forget to square the b. And that equals 64. Subtract 16 over and we get 3b squared equals 48. Divide by 3, 16? Okay. And b squared equals 16. To get b on its own, we have to take the square root of both sides. And don't forget to take the positive and negative square root. So b could be positive or -4. Voila. Unit circle, special triangles.
It sucked. Wasn't that bad though.
So overall, guys, how are you guys finding using the special triangles in the unit circle to solve questions like these? Pretty awesome. I love the enthusiasm.
It's really easy in front of you. But test when it's not.
So constructing the unit circle or
That's also
remembering.
like, do you like should we just like draw it on a test?
I would recommend, like, guys, for your unit test, what I'd recommend is, like, before you even look at any of the questions, maybe you have a scrap piece of paper or something, but you draw out your 3 special triangles, and if you really feel like you'll have enough time, draw out your unit circle. Okay? Personally, I think drawing out a unit circle